fellas are really into something this time, Roy.
I know, Tech, but that's the only way Jack's going to get the hang of this job.
I'm either going to get the hang of it, Tech, or it's going to hang me.
Oh, don't worry, Jack. Roy knows his stuff when it comes to Powerflight.
Well, I appreciate the vote of confidence, Tech, but stick around if you can. Then I won't overlook explaining any important points. Now, an oil leak at the front end of this Powerflight transmission could be due to a worn front pump housing seal. And Jack was about to install a new seal, but I suggested checking for the cause first.
Good idea. And that goes for any model equipped with Powerflight. Too much runout can cause that seal to leak.
I can see how excessive runout is rough on the seal. Where would you check that?
In 3 places, Jack. On the torque converter hub, at the bore of the converter housing, and at the rear face of the housing. Hub runout shouldn't be more than 4 thousandths. If it is, use a torch to heat the front side of the converter. Then quench quickly with wet cloths to shrink the hub back in line.
I remember that hub runout correction story. But look, our hub is well inside the limits. That means we can go ahead and check bore runout.
Right. And to check the bore, you use a fixture and a dial indicator. Mount the fixture inside the converter so the bolt head is behind the converter pump drive lugs. With a wrench, hold the flat of the fixture bolt and tighten the nut. Then mount the indicator on the end of the bolt. Set the dial anvil so it bears on the transmission pilot bore of the converter housing. Then turn the converter a full turn and take your readings.
There should be no more than 10 thousandths total indicator reading.
Supposing runout is more than that, like our job here. Looks like it's about 18 thousandths total reading.
Well, in that case, we'll have to shift the housing on the adapter plate. And we'll want to shift it opposite the place we got our maximum runout reading. Shifting the housing calls for replacing the 2 steel dowels. We have new eccentric dowels available in sizes of 7, 14, and 21 thousandths. When the total reading is greater than 10 thousandths, use 1/2 that total to select the right size eccentric dowels.
1/2? And that means using the size dowels with eccentricity closest to that figure, huh?
That's right, Jack. And Roy can show you how to install those dowels. It's not a tough dowel-it-yourself job.
Oh, no, Tech.
You first loosen the intake manifold bolt that holds the throttle linkage bracket in position and remove the torque converter housing. With a vice grip pliers, remove the 2 old dowels from the adapter plate. In their places, install a pair of dowels, driving them in up to the offset shoulder.
But support that adapter plate when you're installing the lower dowel. Without support, you might damage the plate.
Okay, I'll watch that. Any other tips?
Yep. Position of that slot shows where the dowel has its greatest eccentricity. So keep the dowel slots parallel and the high side of the eccentric in the direction of the point where you notice the minimum runout reading. Make sure the mating surfaces of the plate and housing are free from nicks and dirt. Then install the housing and torque the screws 25 to 30 foot-pounds. Turn the converter and check bore runout again. Now, if necessary, loosen the screws. With a screwdriver, turn the dowels until they shift the housing to get runout within limits. This may take some adjusting and some readjusting. Again, tighten screws 25 to 30 foot-pounds.
All right, Roy. Seems clear enough. Anything special about checking runout on the face?
Well, you'll have to mount the indicator differently.
Yeah, and set that anvil so it bears on the rear face 1/4 inch beyond the bore. Then rotate the converter a full turn and check your readings.
Face runout shouldn't be more than 8 thousandths. And make a note of any low points, because you'll be using shims there to square up the transmission. You'll slip shims over the bolt between the housing and the transmission case. The thickness you pick depends on the runout reading. There's a story in the reference book on selecting shims. Now, after the shims are installed, tighten the bolts 25 to 30 foot-pounds. Also, tighten the manifold bolt that holds the linkage bracket in position. And that's about it on correcting face runout.
Gotcha. And once we're sure that the hub, bore, and face runouts are within limits, then we can go ahead and replace the front pump housing seal.
That's the ticket, Jack. Just be sure the surface of the hub is smooth and clean. Now, when you get this job buttoned up, meet me at that car over there. I've got some service tips that affect power steering on any car. You ought to know about them.
Okay. I'll be with you in a jiffy. And frankly, I can use some service tips on power steering.
Good. We'd better tell you how to correct an occasional case of wandering first.
Tech's right, Jack. Wandering caused by binding or by too much steering wheel free play requires constant turning to keep the car going straight ahead.
I see. Well, where should I start to check for that?
But you gotta find out if the linkage causes the wandering or if the power unit is at fault.
Oh, that's so right. And here's a quick way to tell, Jack. If there's less than 5/8 of an inch free play at the steering wheel with the engine running, and you know the car wanders, the linkage is either loose or binding somewhere. But if there's more than 5/8 free play at the wheel without moving the linkage, the power unit is at fault. Now, since it's easier to start checking the linkage, let's cover that first. Raise the car. Then visually and by feel, check the linkage. Look for looseness. The steering gear arm, for instance, should be tight on the gear shaft. If it isn't, tighten the nut 100 to 120 foot-pounds. And if that's not causing the wandering, check for a bind or looseness at the idler arm. Look for loose or cocked tie rod ends, or loose steering knuckle arms. Tighten or replace any faulty parts.
All right. What else?
Front wheel alignment, of course. Check camber, caster, toe-in, and kingpin inclination, and wheel bearing adjustment. Get it all up to specifications.
As good as done, Roy. I'll make sure the alignment is right.
Fine. Now, remember that more than 5/8 play at the wheel without moving the linkage means checking the power unit. There might be a loose gear shaft adjustment, for example. Now, besides that possibility, the steering worm coupling screw might be loose.
Yeah? I can see that now. Any other things to check?
Two other possible causes, Jack, are a loose worm bearing preload adjustment and too much worm shaft end play in the connector assembly.
I get it. Well, which possibility should I tackle first?
The gear shaft adjustment, Jack. You can correct it by means of this adjusting screw. It moves the gear shaft teeth into closer mesh with the rack teeth on the lower piston rod.
You better make sure the steering gear is properly centered to the overall travel of the gear before you touch that adjusting screw.
Hey, good point. Now, you can center the gear by turning the steering wheel from one extreme to the other. Count the number of turns, then bring it back to the halfway point. Now, once the gear is centered, turn the adjusting screw out until there's backlash at the steering arm. Then slowly turn the screw in until there's zero backlash. Next, turn the screw in not more than 3/4 of a turn to preload the gear teeth properly. Secure this position by tightening the lock nut.
Okay. What's next?
Next, somebody please turn the record. Meanwhile, we'll remove the unit from the car for more checking on the bench.
Once you've checked the gear shaft adjustment on the car, Jack, you'd check free play at the wheel again. If it was gone, adjusting the gear shaft did the trick.
But what if the gear shaft adjustment were okay?
Then you'd check the steering worm coupling screw. If it ever worked loose, there'd be too much backlash in the tube and coupling.
What do I do, Roy? Just use a socket wrench and make sure the screw is snugged down good and tight?
That's exactly what you do, my boy. Hey, you're beginning to show real promise.
Nah, Tech. Don't start picking on Jack. And we've still got the worm shaft bearing preload adjustment to talk about.
I thought we didn't have to do that anymore.
On the tapered roller bearing jobs we do, we have to seat the inner bearings under a load of 20 foot-pounds. And you hold the worm shaft against the bearing at 20 foot-pounds to seat the bearing races. Then, using this special wrench and another torque wrench, tighten the adjusting nut clockwise to 15 foot-pounds. Now, turn the worm shaft several times next to seat the bearings. Then, loosen the adjusting nut. Next, Jack, using a torque wrench and this special tool, hold the worm shaft counterclockwise at 5 foot-pounds against the inner bearing. Then, retighten the adjusting nut clockwise to 5 inch-pounds. And finally, stake the nut to index with the slot in the worm shaft. That winds up the worm bearing preload adjustment.
Okay, Roy, but I have a question. There's still one more possible cause of free play that we haven't covered yet, right?
Yeah, Jack, and here's that story. There might be too much worm shaft end play in the connector assembly. If you find this condition, replace the worm and connector as an assembly.
I see. Now, does that wrap up the possible power unit causes of wandering?
That it does, Jack. However, power steering oil leaks are something else we ought to talk about.
What kind of leaks, Roy?
Well, if you get a repeat O-ring replacement job, for instance, sometimes you find an O-ring was damaged during installation.
During installation? Are you sure?
Now, my boy, don't look so innocent. You might have done it yourself. It can happen to anybody.
Tech's right, Jack. O-rings can be nicked or sheared if there's a rough edge or burr on the valve operating rod or on the upper and lower piston rods. Always check a ring groove carefully for this roughness. If you spot any, dress it down before installing a new seal. And also, apply lubricant to the O-ring so you can roll it into place more easily. Now, use this housing retainer flange to locate outside and inside pressure leaks. It helps pinpoint possible leaks, and you can use it before disassembling the power unit.
You can use this tool to test a repaired unit for leaks before you install the unit in the car, Jack. It checks the job on the bench and saves lots of extra work.
Sounds like a good tool. Just how do you use it?
Well, first, of course, you mount the steering unit on the body holding bracket. Then you install it on the mating surface of the lower housing after the upper housing is removed. Remove the worm connector assembly next. Connect the pressure and return hoses to the pump as usual, and with a cloth, wipe any traces of oil from the housing and upper piston rod. Start the engine to get the pump going. And with a pair of pliers, push the control valve down to build up pressure on the upper side of the piston.
Get that valve down far enough, Jack. But remember, don't hold it down too long, as temperature and pressure will build up right away.
Yeah, Jack, that's a good point to keep in mind. Now, while the power unit is under pressure, if high-pressure leaks are present, you'll notice them at one of the following places. First, at the upper piston rod.
Meaning that I'd have to replace that seal, huh?
Right. Next, you might see a leak at the upper end of the valve rod. That would mean the O-ring seal in the upper end of the upper piston needs replacing. Third, you might spot leakage at the reaction seal retainer. And that means the reaction control seal needs replacement.
Okay, Roy. That's a pretty clear picture of possible leaks and how to find them.
Fine. Now, that about covers power steering service, Jack. Hey, how would you like some new information on the center plane brakes?
Center plane brakes? Sure. I can use all the brake information I can get.
Good. You know, there's a definite system of checks you can make to eliminate an occasional howling or groaning noise from the rear center plane brakes on a car. First, see that the rear spring U-bolt nuts are torqued 65 to 80 foot-pounds. That's so the axle won't move on the springs. And second, pull the wheel and drum and check the brake lining wear pattern. If there's only partial contact, check for drums out of round, misalignment of the shoe, or a distorted support plate. Use a reliable gauge to see if the drums are out of round more than 5 thousandths. If they are, true them up on a lathe and polish out any roughness. Inspect the support plates for distortion and loose anchor pins next. Use a screwdriver between the plates while you press against the end of the pin to check looseness. If the pins are loose, remove the support plate from the dust shield. Rest the pin on an anvil and peen the end until the pin is tight. Be sure both plates are in good alignment. Now, when you install plates on the dust shield, tighten the bolt nuts to 35 foot-pounds. That keeps the plates from vibrating.
Okay, I'll remember that.
Check the shoe guide springs, too. They hold the shoe steady and cut down vibration. Bend the springs to increase tension, if necessary.
Yeah, and here's something else, Jack. There should be about a half-inch between the two spring retainer prongs. Bend the prongs to get this distance if needed. Now, during assembly, fasten them securely so the guide spring won't slip off. And replace any warped shoes or support plates. Finally, button up the assemblies and road test the job.
What if my road test showed no improvement?
Well, then replace the rear shoes with new ones of new design and replace the springs with new 5-coil return springs.
Notice that the new shoes have loops on the outside edges. The new return springs hook into those loops, so the shoes are provided with both a return force and a side thrust.
Put the long hook of the spring in the shoe and the shorter end in the spring link. Install the original guide springs and retainers making sure they have the right tension to hold the shoes firmly in place.
So that's how you correct the noise on rear center plane brakes.
That it is, Jack. Now, how do you feel about Powerflite, power steering, and brake service?
I feel like I've just had an extra special education. You and Tech sure brought me up to date on some service tips I really can use.
Glad to hear it, Jack. As long as you and all of our technicians stay up to the minute, we'll keep on giving our customers top service. That, of course, is our #1 job.